Good afternoon, ladies and gentlemen. Today we're going to be graphing linear inequalities. So our goal today is to be able to graph inequalities in the coordinate plane. I highly recommend for this lesson that you have a colored pencil. It can be any color you'd like, and you want to either have a student ID or a ruler or some sort of a straight edge. That will allow you to draw nice straight lines today. Steps to graphing linear inequalities are as follows. Step 1 is to put your inequality into slope-intercept form, just like we did for our graphing linear equations. We have some different things here. If we have a greater than sign, our type of line is going to be a dashed line. If we have a less than sign, it's still going to be a dashed line. That means that if we had a dot that was on the dashed line, it would not be part of our solution set. On the other hand, if we have a greater than or equal to sign, that's going to be a solid line. A less than or equal to sign is also going to be a solid line. And that basically means if your dot is on the line, that your boundary is part of your solution set. So if we have a greater than sign, our shading is going to be above the line. So anytime you have a greater than sign, it's going to be shaded above. That means if we have a less than sign, it's going to be shaded below. Let's go ahead and look at a couple examples here and see how we do. So first thing, our equation is in slope-intercept form, so that's awesome. So that means we can start recognizing some different parts of information. So on this thing, my y-intercept is going to be 0, -5. My slope is going to be m equals 3/1. My inequality tells me that this is going to be a dashed line. And because it's a less than sign, it's going to be shaded below. Let's go ahead and actually graph that here. So I start at -5, because that's my y-intercept. I'm going to go up 3/1. So I go up 3/1, up 3/1, up 3 squares over 1 square, up 3 squares over 1 square. Okay? Now, I know this is going to be a dashed line, so I'm going to go ahead and make a dashed line like so. Here's where I'm going to go ahead and shade. The part I'm going to shade is going to be below, so I'm going to shade all of the area that is below that dashed line. That means if I put a dot anywhere on this thing, as long as it is in my shaded area, it's going to be part of my solution set. So just to be sure, I'm going to just show you what I mean. This is part of my solution set, so I would say yes, that is part of my solution set. If I put a dot out here, I would say no, that's not part of my solution set. So once again, something like this would be yes, it is part of my solution set. If I put a line on the dashed line here, because it's a dashed line, it is not part of my solution set. So I would say no, it's not part of my solution. Let's look at another example. Here we have y is greater than 4. I'm going to rewrite this in a different way so it just looks a little bit better for us. So I have y is greater than, I have 0x's plus 4. Now, my y-intercept this time is going to be 0, 4. And my slope is 0/1. This line is going to be dashed. And it's going to be shaded above. because I have a greater than sign. Now let's go ahead and graph this thing. So I start at 0, 4. That's right here. My slope tells me to rise 0 and run 1. So I rise 0, run 1. Rise 0, run 1. Rise 0, run 1. And you can probably see that it is simply just making a straight line like so. So I'm going to go ahead and make a dashed line. Put my arrows. And we said it is going to be shaded above. So I'm going to go ahead, take my colored pencil, and I'm going to shade it above. Okay. And just to be clear, when I do this, I want to make sure. So if I put a dot on the black or on the blue line right there, that would be a no because it's on a dashed line. If I put a dot in here, yes, this is part of my solution area. If I put a dot here, I would say no, that's not part of my solution area. If I put a dot here, I would say no, that's not part of my solution area. So the only things that are in my solution area on this problem is that colored in area. Our next problem is x is less than or equal to -6. So on this one, it is a little bit tricky because I don't actually have a slope-intercept form I can put this into because there is no y. So what I actually have to do is it is simply going to be a straight up and down line. Anytime you have x is equal to or x is less than or equal to or x is greater than or equal to, it's going to be a straight up and down line, and it's at whatever number this is. So in this case, it is -6, so that means I am at -6. And it's going to be a solid line because it's an or equals to sign, just like so. Now, you'll notice it says x is less than or equal to -6. So if something is going to be less than, that means it's going to have to shaded below or in the less portion of this thing. So my solution area on this one is that highlighted side. Now we do have something slightly different on this problem as well. In this case, because I do have a solid line, just like normal, if I have this, this would not be in my solution area. This would be, we would say yes. However, if I'm on the line this time, that's actually okay because it's a solid line. So we would say yes for that one. This is a special case if we just have x equals some number. Let's look at our next example. So here we have to get y by itself. So to do that, I'm going to subtract 2/3 x on both sides. So I'm going to say minus 2/3 x minus 2/3 x. So I'm left with y is greater than or equal to -2/3 x plus 6. Now I can answer the questions I usually answer here. So my y-intercept is 0, 6. My slope is -2/3. This is going to be a solid line because it's a or equals to sign. And this is going to be shaded above because it's a greater than sign. So I'm going to go ahead and graph that. So I put a dot at 6. My slope tells me to go down 2/3. So I go down 2/3, down 2/3, down 2/3. I can also go backwards in that. I know it's going to be a solid line, so I'm going to go ahead and draw a solid line there. And then I know that I am shading this thing above, so I'm going to go ahead and do that. And I am all done with the problem. Let's look at our next problem. We actually don't have to do that one. So we are actually all set with all of our work for today. Have a great day. I will see you guys next time.